Hi, good morning, everyone. So my name is Meditya Wasesa, and today we are going to talk about two sample tests for related populations. Yeah. First of all, let's us discuss about the fundamental philosophy. Yeah. Okay. Oh, okay. What is the difference, or what are the differences between one sample test and two sample hypothesis tests? Just recalling previous videos, yeah, hypothesis in one sample context means that hypothesis is a claim about a particular parameter of a population, yeah, of one or singular population. Say we have a populations of the city of Bandung, yeah, and the claim could be the average monthly income of Bandung citizens, or it could be also concerning the parameter concerning proportion. For example, there is a claim that states the wealthy people in Bandung equals to 10%. That's its singular claim. Yeah. So hypothesis yeah, could be stated as, for example, here we stated the monthly income of citizens in Bandung is equals to 1,000 US dollar, or could also be the monthly income is greater than or equal to 1,000 US dollar. And also we can also state, for example, the monthly income of Bandung citizens is lower than or equal to 1,000 US dollar. Yeah, so that's the only example. And that is hypothesis, yeah, one-sided hypothesis. And how do we test it? Yeah, hypothesis test is evaluates whether the hypothesis statement or the previous claim is indeed correct, yeah, or can be accepted or must be rejected. And how do we do that? Yeah, of course, we have the populations, and then we have the claims, and then how to test whether it's right or not. We pick several respondents, yeah, or data points, and then we write down the value of it, and then we make statistics. Yeah, we'll calculate the mean or standard deviations, and then via this sample statistics, yeah, we compare it to the claimed statement or the claimed hypothesis. And if it's near, yeah, to the statement, then usually we accept the hypothesis. But if the samples statistics finding is far away from the claimed hypothesis, then we usually reject the hypothesis. Yeah, that's in a philosophical manner. But now we step on into the two sample hypothesis. We also discussed it earlier, but yeah, in two hypothesis contexts, yeah, the statement concerns two different populations. For example, the population of city of Bandung and the city of Jakarta. Yeah, and then the hypothesis statement could be, okay, the monthly income of people in Bandung is equals to Jakarta, or yeah, or maybe the monthly income of people in Bandung is lower than or equals to Jakarta, or the other directions. But basically, hypothesis into sample to sample context usually concerns different populations, and how to test whether the claimed hypothesis is right or wrong. It's also the same procedure. Usually we take respondents or data points from each of the populations, for example, Bandung and then Jakarta. Yeah, and then using the sample data points of Bandung, we calculate the statistics, and also using the data points of respondents of Jakarta, we calculate the statistics and the sample statistics of city of Bandung, and then sample statistics of the sample statistics population of city of Jakarta. We compare, yeah, the values and see whether the comparisons that we find by studying the sample statistic calculations of both samples are indeed close to the stated hypothesis. Yeah, if it's close, then usually we accept the hypothesis, but if not, then we reject it. Now we stepped on to the two sample test, but for related populations. Yeah, how does it differ? Yeah, okay. Two sample hypothesis tests can be divided into two cases. Yeah, the first one independent populations, and the one that we are going to focus on is related populations. Yeah, okay. For independent populations, the observed populations are somehow independent of each other. So let's see, for example, we go again to the case of city, comparing the monthly income of peoples in Bandung and populations. Yeah, the sample we pick in the city of Bandung, for example, 100 or maybe 10, yeah, is randomly picked without recording the identifier of the sample. Yeah, we just simply pick, okay, respondent one, what is the incomes, respondent two, what is the income, respondent three, what is income, and so on. Also, for the second populations, yeah, we record what is the income, respondent one, respondent two, respondent three, regardless who respondent one, two, three is. Yeah. And the data recapitulation of this independent population could be written as follow. Yeah. So for example, the first respondent is Bandung 7 million rupiah per month. Yeah, the monthly income. The second respondent is 4 million, 5 million, and so on in Jakarta also. So we have the record of the data points, yeah, of the or the record of the samples like this. But in related populations, yeah. Uh, uh, so even though, for example, we observe the monthly income of people in Bandung and the monthly income in people in Jakarta, yeah. But the observed populations, yeah. So the observed populations are independent of each other. Can be independent of each other. For example, the people are in Bandung are somehow independent of what the people in Jakarta are doing, but the respondent itself have similar characteristics. Yeah, there are similar characteristics of each data or respondent in both populations. Yeah. So I write like this, yeah, population one and then population one accent. And then if you see carefully the sample identifier that I put on, so this is X bar one, this is X bar one accent. What does it mean? I will show you in the following slides. Yeah, if previously I stated like this, yeah, this is the sample record of independent population, but in related population, I put identifier on the data record. So there is an extra column here, yeah, that states the uh, the pairing the pairing characteristics or the similar characteristics that make the data point in Bandung and Jakarta could be related. Yeah. For example, yeah, in independent populations technique, I put 10 different people, yeah, regardless of who he is. Yeah, I don't care what is the title, I don't care what is the name. Yeah, but in related population, I specifically identify the respondent. Okay, you are, for example, a fresh graduate in Bandung. What is your monthly income? Oh, 3 million. And then I look for similar characteristics respondent in Jakarta. Okay, also must be fresh graduate, and then I compare it. And then I record the data, okay, 5 million. Then, yeah, the respondents data table that we have is having similar paired characteristic, which is fresh graduate. Okay, and then the second respondents, okay, for example, I want to look for another people with another background, for example, a general manager, yeah. And then, okay, you're general manager. Okay, what is your salary in Bandung? Or 20 million. And then in Jakarta, I also seek for respondent who also is a general manager. Yeah, and that is, and then I record it. By using this method, then we can see some, yeah, quote unquote, the apple to apple comparison between populations in Bandung and Jakarta in more precise manner. Yeah, because we pair, you know, we matched the the data points, yeah, based on similar characteristics. That's why here in related populations we have the notions of match samples. Yeah, so the data identifier is the same, but yeah, you know, the data records come from different populations. So there are two different populations, but they have similar characteristics. Yeah. Okay, this is one case of related populations. And the other type of match samples is here. Yeah, so if we can see here, this is population 1 and this is population 2. So related population can be yeah, categorized into two different bins or two different groups. One is match sample and the other one is repeated measurements. So it could be that, okay, repeated measures usually concerns about experiments, longitudinal experiments. Yeah, so okay, I measure for one person, I measure at specific time, and then after the following period, I measure again the value of interest. For example, Budi. Yeah, previously Budi was in Bandung. Yeah, and then after he moved to Jakarta, yeah, what is the increase? What is the salary? Yeah, so here I have the second piece, which is repeated measurements, which with the main emphasis on the before and after event. Yeah, for example, Budi, while he's still in Bandung, the monthly income is 3 million US dollar. Sorry, 3 million rupees. And after he moves to Jakarta, the monthly income becomes 5 million. Yeah, and then for example here, yeah, Rahman, for example, when he was staying in Bandung, the monthly income was 30 million rupees, and then after moving to Jakarta, the salary becomes 50 million. But still, if you see related populations, there are values in both of the populations, in this case Bandung and Jakarta, but there is a matching identifier which bind these two records. So these two records is somehow paired to a single identifier. Yeah. So here we can see, yeah, it is independent and related populations. What is the difference? Yes, sure. Yeah, here there in independent difference there is no pairing identifier. Yeah, but in related population there is a pairing identifier, yeah, or a match identifier in which the characteristics are the same, and the related population could be uh, uh, categorized as matched samples. Yeah, you know, people with the same job title, the same condition, position, or the related population case could be also before studying before and after event. Yeah, before and after effect, like the second case in which the respondents is recorded on his monthly income before moving to Jakarta and after moving to Jakarta. So I think that's it. Yeah. So in two sample hypothesis, there are two cases. First is independent. In independent, you know, the data points are not matched or not paired based on a single similar identifier, but in related populations matched into a singular matching identifier, and the case could be match identifier or a repeated measurements, which indicates before and after effects. Okay, I think that's my explanation concerning the principal philosophy of this related populations. Yeah. Okay. See you in the next video. Bye.